Okay, so noticeably missing from our graphing have been tangent graphs. Sine and cosine graphs are definitely much more common, especially you'll see the way that sine and cosines have been modeling things like high tide and low tide and temperatures. Tangent's going to have a tougher time modeling real life scenarios, so I don't think they stress it as much for that reason, and it's also going to look vastly different than your sine and cosine. But we're going to do the same kind of thing here. And we're going to come up with a table of values. Our x-axis stands for the angle measure, and our y-value stands for that value. So if we, in our angle measures, by the way, are right now in terms of pi. So I'm going to go through our first quadrant. That's 0, pi over 6, pi over 4, pi over 3, and pi over 2. Now, if you remember your tangent values, the tangent of 0 is 0. The tangent of pi over 6 is root 3 over 3. The tangent of pi over 4 is 1. Tangent of pi over 3 is root 3. And the tangent of pi over 2 is undefined. So because that one is undefined, I'm actually going to do something a little bit different here, and you'll see why once the graph is constructed. We're definitely going to graph the first quadrant, which is from 0 to pi over 2. But we're also going to back up and go back to negative pi over 2, which will also be undefined. Negative pi over 6 will be a negative root 3 over 3, because tangents are negative in this quadrant, right? All students take calculus. Negative pi over 4 will be with a negative 1, and negative pi over 3, the tangent of negative pi over 3, is negative root 3. So these are really going to be the coordinates for these points. And again, because these two are undefined, I'm actually going to graph the section in between negative pi over 2 and positive pi over 2. So starting with, I guess, pi over 2 and negative pi over 2, because those are undefined, those are actually asymptotes on your graph. So vertical asymptote at negative pi over 2, and then a vertical asymptote at positive pi over 2. And then we'll look at all that happens in between them. And we'll start with the first quadrant still. So we'll start with a 0 radian angle with 0. And root 3 over 3. So when we get to it, so if this is pi over 2, this is pi over 4. And if you want to think of this as 30 degrees, 90 degrees or pi over 6 is going to be here-ish. And the y-coordinate is root 3 over 3, which we need to figure out the decimal of that, just to give us something that's graphable. Root 3 divided by 3 gives us 0.577. So right around there, I'm going to go to 0.577-ish. And then pi over 4 is this one, which is 1. And pi over 3 will be over here somewhere. That's about a 60-degree angle, so 2/3 of the way there. And the y-coordinate for that is root 3, which is 1.7. So that came from there, and that root 3 is 1.7. 1.7. What is going to happen is, as you go up, your tangent values are increasing indefinitely until they get to undefined. So this kind of is going to look like this, which is typical. When we approach a vertical asymptote, we kind of shoot up towards infinity, or down towards negative infinity. And then on the flip side of things, negative 30 degrees or pi over 6 with a negative root 3 over 3, that's a negative 0.577. Negative pi over 4 was negative 1. And negative pi over 3 was negative root 3, which is that 1.7-ish. A similar thing happens down here. And that's really the section of the graph that just continuously repeats itself. So the period, that's just one cycle. We would just translate that over, and you'll see a second cycle. Again, in the middle of that, you get that, and without having to do all the values over and over again, it's just going to be this general shape. And then we would translate that over here, so we'd have another asymptote, and it would do that again and again. So this cycle, that's a tangent graph. If you look on your graphing calculator and you just do a tangent of x graph, and you do your window from 0 to 2 pi, let's say, and your y min negative 10 to 10 will do, and our mode has to be in radians. If we graph that, you're going to see kind of the tangent graph. Now, again, we only are looking from here to here. 0 to 2 pi is the way I set this, but you kind of see that structure, and it just repeats. So if I actually went from negative 2 pi to positive 2 pi, I'd see, you know, more of this pattern going over and over and over again. Okay? So it's cyclical, just like sine and cosine. It's a pattern that keeps repeating itself, but quite a bit different. There's no such thing as amplitude. It does not exist, because it's not a wave. There is a midline, I guess you could say. The midline is at 0, and you can shift these up and down off of that. So we'll say it's at y equals 0, although it's not really the middle of the wave. The period is different. Negative pi over 2 to pi over 2. For sine and cosine, the period was 2 pi, but for tangent, it's only pi. So our period formula is actually 2 pi over b, only for sines and cosine graphs. Okay, but for tangent graph, your period starts as being pi, and then you divide it by b if there is a horizontal stretch or compression. Okay? As far as even, odd, or neither, if we flip this guy upside down, I'll do it more on my calculator, it'll be easier to see. It's the same graph upside down. That makes it an odd function. Okay? As far as domain, negative infinity to infinity all work, except for where all of these asymptotes are. Negative 1 pi over 2, positive 1 pi over 2, 3 pi over 2, 5 pi over 2. It's actually going to be k pi over 2, where k is odd. Any pi over 2 where k is odd, so 1 pi over 2, 3 pi over 2, 5 pi over 2, x cannot equal that. Other than that, it's all real numbers. Your range is all real numbers. It's going to go down forever and up forever. So that is, x is an element of all real numbers. Or if you did interval notation, you could do negative infinity to infinity. I'm not going to write these down in intervals because there would be too many of them, but it's positive, meaning above the x-axis, from 0 to pi over 2, from pi to 3 pi over 2, from 2 pi to 5 pi over 2, and so on. And your negative intervals are from negative pi over 2 up until 0, positive pi over 2 up until pi, 3 pi over 2 up until 2 pi, and so on. Because there's an infinite list of those, I'm not going to actually write those, but just to remind you what positive means above the x-axis. And if you think about it, just in your first cycle from 0 to 2 pi, so just this section, tangent is positive in the first quadrant from 0 to 2 pi, 0 to pi over 2, that's here. And then again in the third quadrant from pi to 3 pi over 2, that's here. That makes sense with our all students take calculus. Positive in the first quadrant and positive in the third quadrant. That's the first quadrant. Here's Q1, here's Q2, here's Q3 where it's positive again, and here's Q4 where it's negative again. So some interesting parallels and connections to be made there, but that's the graph of a tangent function, and we can transform that just like we do other things. So there's your parent graph, and here is a tangent graph undergoing a lot of transformation. So y equals 2, tangent, I still have to factor out that 2, just like I did with sines and cosines. When I divide a 2 away from pi, that's going to turn it into pi over 2. Okay? So there is, let's start with horizontal, inside out. This is number 1. That's a horizontal compression by a half. So our period, which used to be pi, is being divided by 2. So our period is now pi over 2. So it's been shrunk, and that reflects the horizontal compression. Then this comes second. Remember, in order of operations, that would actually come first, and that would come second, but tangent does everything, or horizontal does everything backwards. So this got shifted right, pi over 2. So we would compress everything first. We would take this graph and compress everything first, and then shift the starting point over pi over 2. Then would come that guy, which is a vertical stretch by 2. That's not going to really do much other than like kind of flatten these. They won't have so much of a curvature. They'll kind of stretch out. I'll just even do this one and change it to 2 tan x. And you'll see just how it kind of, they stretch a little bit more flat than the parent graph. And then the last one is this shift, vertical shift up 1. So, I'm sorry about that. So the transformation kind of game is still happening. If I go back, if I just show, I'm going to get rid of the vertical stretch, but if I show the shift up 1, you'll see the original. And then you'll see everything shifted up 1. It's harder to see the shift up 1 as the slope gets steeper, but that does shift up 1. Really, this critical point went up 1. This critical point went up 1, and so on. Delete. You'll see if I put the 2x in there, you'll see the horizontal compression happening. Again, here's your parent graph, and here's your horizontal compression. You just have way more cycles. So as the horizontal compression happened, like this blue line got pushed into that red, this blue line got pushed inward towards that red. Your number of cycles doubles, so the frequency doubles. It became 2. And then lastly, if we shift, and I'm just doing one transformation at a time because it would be hard to see otherwise. If we shift this pi over 2 to the right, again, here's your parent function. And we're going to shift everything pi over 2 to the right. So pi over 2 is where the asymptote was. Now that's where that little 0 is going to push to. And you see a shift to the right. So some of the basic stuff is the same. Like I said, we haven't seen too much on tangents, but I would feel really bad if some tangent graph came up and you were totally thrown off because you never saw that before. But the structure is still the same. It's A, tangent, B, x minus c plus d. So we've got what's a vertical stretch, a horizontal stretch or compression, which affects the period of a shift right, and kind of a shift up or down. And then a negative tangent graph, we should just look at that. A negative tangent graph compared to the positive tangent graph. If you notice, the positive tangent parent graph increases the whole time. It's increasing. A negative is a vertical flip. So when you flip this vertically, it actually decreases the whole time. So if you see a negative tangent, it really kind of decreases the whole time as opposed to increases. So that's all I'll say about that. Like I said, there's no homework on the tangent stuff. I just wanted you to see it. And you have your spiral as homework.